P of 2, or with a 2 in parentheses, means we'll take a 2, plug it into the P equation, and we'll plug a 2 in for the x values. So rewriting the P of x equation, we'll have 3, but in place of x, we can plug a 2 in, 2 squared, minus 2 times 2 plus 5. Simplifying, exponents first, 2 squared would be 4, 3 times 4, negative 2 times 2 would be negative 4, and plus 5. Equals 3 times 4 would be 12, and then minus 4 plus 5. Adding and subtracting from left to right, 12 minus 4 would be 8, 8 plus 5 would be 13. So in this question, P of 2 equals 13. Second question, R of negative 3. In this question, we'll take negative 3 and we'll plug it into the R equation for the variable x. Rewriting the R equation, we have x cubed, which in this case would be negative 3 cubed, plus x, which would be plus a negative 3, and then plus 1. Simplifying, negative 3 cubed, negative 3 times itself 3 times, and that would be negative 27, plus a negative 3 would be minus 3, and plus 1. Negative 27 minus 3 would be negative 30, plus 1 would be negative 29. And last question for the section, R of 3a. With a variable, we can plug 3a in and replace that with the other variable x. So rewriting the R equation, x cubed would be 3a cubed. And instead of plus x, we'll have plus 3a plus 1. Simplifying from here, the cubed power again will go to each coefficient and each variable in the parentheses. So 3 cubed would be 27, and a cubed. Plus 3a and plus 1 would stay the same. Since there's no more like terms to combine, this will be our final answer. 27a cubed plus 3a plus 1. Title of the last section is Describing Functions. The definition or way we'll describe function has 3 parts. We will first describe the end behavior. End behavior will be the left side and right side of the graph and which direction it points. We'll also describe odd or even based on how the graph looks. And the last part will describe or state the number of zeros that the graph has. First graph will look like. This graph is also known as a S-curve. Starts at the bottom left, curves 2 times, and points up to the top right. For this graph, again, we'll describe it in 3 ways. We'll describe the end behavior, which again is the left side and right side of the graph. We'll describe if it's odd or even, and we'll also state the number of zeros for the graph. For the end behavior of the graph, we can start at either the left or the right side. If we start at the right side of the graph goes up or up to positive infinity. So to write that, we can put f of x, which represents the graph, and we can draw an arrow after it, which represents goes to, and we'll put the sign positive infinity. So f of x, the graph, goes to positive infinity, which means the graph goes up to the right, as x also goes to positive infinity. What this means, x goes to positive infinity, means we're talking about the right side of the graph, the positive x's. The graph itself also goes up to the top, positive infinity. The second part for end behavior is the left side of the graph. The left side of the graph goes down to the left. So likewise, we can put f of x, which again is the graph, goes to, since it goes down to the bottom or negative numbers, this would be negative infinity, as x also goes to negative infinity. And again, this means the left side of the graph, since we're talking about negative numbers, the graph also goes down to the negative side or negative infinity. After end behavior, we can describe if it's odd or even. Looking at the graph, if one side points down and one side points up, this would be an odd graph. If the lines point opposite directions, that'll make it odd. If they pointed the same direction, that would make it even. And for the number zeros, we can look at the graph. Zeros are where it crosses the x-axis at. This graph crosses once, twice, or 3 times. So this graph will have 3 zeros. So we have the end behavior, a odd graph, and 3 zeros. Last graph we'll look at for this section. Graph looks like a parabola shape, except it has 2 bottoms of the graph, or a W shape. For this graph again, we'll describe the end behavior, odd or even, and the number is zeros. If again we start at the right side of the graph, we can put f of x, which represents the graph, goes to. The right side of the graph goes up, so f of x goes to positive infinity, goes up to the top, as x also goes to positive infinity. And again, this means as x goes to positive infinity, which is the right side, the graph goes up to positive infinity. And the second end behavior, the left-hand side, f of x goes to. The left side also goes up to the top, or positive infinity, as x goes to negative infinity. For the left side of the graph, the x values will be negative, or goes to negative infinity. The graph also goes up to positive infinity. The second part of describing functions, odd or even. Since the graph points the same direction, points up in both directions, this would be an even graph. Even again is when it points the same directions. Odd would be if it points opposite directions. And the last part's the number zeros, how many times the graph crosses the x-axis. In this case, it's 1, 2, 3, 4. So this graph would have 4 zeros. So describing this function, we have the end behavior. It's an even function, and it also has 4 zeros. Types of graphs. Types of graphs are based on the degree and the leading coefficient. There's 4 types of graphs, separated by the degree that they have, either odd or even, and the leading coefficient, either positive or negative. Looking at the first 2 graphs, if they are even, even means it has an even degree, like 2, 4, 6, or 8. If it's an even degree, both sides either point up or both sides point down. If it's a positive leading coefficient, a positive number, both sides will point up. If it's a negative leading coefficient or negative number, both sides will point down. And likewise for a odd function. Odd again means a odd degree. like 3, 5, 7, or 9. If it's an odd function, it either starts at the bottom left and goes to the top right, or it starts at the top left and goes to the bottom right. If it's a positive coefficient, again a positive number in front of the degree, it'll start at the bottom left and go to the top right. If it's a negative coefficient, it'll start at the top left and go down to the bottom right. All the curves in the middle of the graph are based upon the rest of the function. Title of the first section today is Graphing. Determine zeros. And max/min. In this section, we'll graph polynomials, we'll determine the zeros, and we'll find either the max and or the mins. First function we'll look at, f of x equals x cubed minus 2x plus 6. Looking at this function, we can decide the shape of the graph based on the previous section. This is an odd graph. X cubed would be an odd graph, and the coefficient in front is positive, so we'll have odd and positive. So looking back at the tables we just did, this graph will start at the bottom left and curve up to the top right. To get the precise graph, we can make a t-table, x and y. We can use any numbers for x and y, but the numbers we'll use for this section will start at -2 and go up to +2 using 5 values. So we'll have -2, -1, 0, 1, and 2. Plugging these numbers in to the expression, we'll find f of x, or the y value, and then we can graph the 5 points on the next y-axis. Starting with -2, if you plug a -2 into the expression, -2 cubed would be -8. -2 times -2 would be +4, and adding 6 to that, we'll have -8 plus 4, which is a -4, plus 6 would be a +2. So our first value would be 2. Repeating for the next 4 values, -1 cubed would be -1. -1 times -2 would be +2, and plus 6. -1 plus 2 would be 1, plus 6 would be 7. Plugging a 0 in, the x's will be zeros, we'll add 6 to that, so 0 will be 6. Plugging a 1 in, 1 cubed would be 1, -2 times 1 would be -2, and plus 6. 1 minus 2 would be -1, plus 6 would be 5. And last number we'll plug in 2. 2 cubed would be 8, minus 2 times 2 would be 4, plus 6. 8 minus 4 would be 4, plus 6 would be 10. Taking these 5 values now, we can graph them on a xy axis to get the graph for the function. The first point that we have is -2 and +2. Second point is -1 and 7. And 0, 6, 1, 5, and 2, 10. So graphing the 5 points, we'll connect them in order from left to right that we graphed. And we'll get a shape that looks similar to the graph that we originally thought it would be, which is starting at the bottom left and going to the top right. To finish this graph, we want to find these zeros. The top right of the graph goes off to infinity, so there'll be no zeros on the right hand side, but the left side of the graph will continue to drop down, so we'll have some zero on the negative x-axis. To find that 0, we can plug another number in by continuing the t-table. Since we left off at -2, we can plug in -3 to see if that's where the 0 would be. If you plug a -3 in to the original equation, -3 cubed would be -27. -2 times -3 would be +6, and +6. -27 plus 6 would be -21, and -21 plus 6 would be -15. So -3, if we drop the graph down 15 spots, we'll have another point that we can graph and connect that to our line. Since we know this is a odd positive graph again, the graph will continue to drop to the left-hand side. To find the zeros for this graph, looking at the x-axis, the 0 will cross between -2 and -3. So our zeros, since we don't have an exact value, we can put between -3 and -2. And the last part for this section, max or min. Max or min will be relative max or relative min. What that means is we'll ignore all the negative values that go down to -infinity, and we'll also ignore all the positive values that go up to +infinity, and just look at the middle of the graph with the curves. The relative max will be the top of the curve, and the relative min will be the bottom of the curve. So for the max for this graph, we'll have x equals, and the top of the curve in the middle of the graph occurred at -1, so x equals -1. For the relative min, again ignoring the negative values, but back at the middle of the graph, the bottom of the curve was at +1, so the relative min is at x equals +1. So we'll have our graph. We have 1, 0, which is somewhere between -3 and -2, and we have one relative max and one relative min. Title of the last section today is More Graphing. Determine zeros. And max/min. In this section, we'll continue to graph polynomials. We'll determine the zeros for those polynomials, and we'll find any relative max or mins. First question, and only question for the section, f of x equals -x cubed minus 4x squared. Before you graph functions, it's a good idea to figure out the shape of the graph. This graph is an odd function, since the degree or highest exponent is odd, and it's also negative since the coefficient is negative. If we have an odd negative function, looking back at the examples we did at the beginning of these sections, odd negative graphs would look something like this. Starting at the top left, have some curves in the middle, and then go down to the bottom right. To graph functions again, we can use a t-table, xy t-table. And you can use any numbers, but the numbers we'll use for the section will be -2, -1, 0, 1, and 2. Starting with these points, we'll get an idea of what the graph will look like, and then we can add more points as needed to get the correct shape. Plugging a -2 in, we'll have negative, and a -2 cubed would be -8. -8 with a negative outside would become a +8. So -2 plugging into the first term would be +8. -2 squared would be 4. 4 times a -4 would be -16. So our first y value would be -8. continuing on, plugging a negative 1 in. Negative 1 cubed would be negative 1. With a negative outside though, that would become a positive 1. And negative 1 squared would be positive 1 times a negative 4 would be 1 minus 4, or negative 3. Plugging a 0 in, both x's would be 0, so the y value would be 0. Plugging a 1 in, 1 cubed would be 1. The negative makes it a negative 1. And 1 squared is 1 times a negative 4, which will give us negative 5. And 2 cubed is 8. With the negative outside, we'll have negative 8. And 2 squared is 4. 4 times a negative 4 is negative 16. Negative 8 minus 16 would be negative 24. So taking the 5 y values that we have, we can graph those and add more as needed depending on the shape of the graph. Graphing from here. The first point we have is negative 2, negative 8. Second point is negative 1, negative 3. 0, 0, 1, negative 5. And 2, negative 24. The 5 points again, we can connect in order from left to right. And that'll be the graph for this function so far. Keep in mind though, we want the graph to finally look like the original shape, a odd negative, which goes down to the right, which is fine. But the left-hand side for odd negative graphs points up to the left, which means this graph on the left-hand side will have to curve back up and we'll have a 0 somewhere on the negative x-axis. To find those points, we'll just continue using points, plugging them into the equation to find out where the graph turns around at. So our t-table we can continue. Since we did negative 2 on the left-hand side, we can plug in a negative 3 and see where negative 3 would have the graph. Plugging a negative 3 in, negative 3 cubed would be negative 27. With that negative outside, would make it positive 27. And negative 3 squared would be 9. 9 times a negative 4 would be negative or minus 36. So 27 minus 36 would be negative 9. Graphing that point, it's actually one spot below our last point, so the graph continues to go down, but it starts to turn around since the distance is getting smaller and smaller each time the graph goes. So again, we can continue picking points until the graph curves back up and we'll find the 0 for the graph. Plugging the next point in, negative 4. We'll have negative 4 cubed, which would be negative 64. The negative outside makes it a positive 64. And negative 4 to the second power would be 16. 16 times a negative 4 would be negative 64. So we'll have 64 minus 64, which will be 0. Graphing this point, negative 4, 0. We'll have the 0 for the graph, and we'll also have the graph turn back up and go up to the top left, which will match the shape of the graph that we should have. So this will be the graph for the function. And last part, we can determine the zeros. Zeros again are where it crosses the x-axis. In this case we have two zeros and they both point at integers. We have negative 4 and 0, so the two zeros would be negative 4 and also 0. To find the max and min, or relative max and relative min, again ignore the ends of the graph where it goes off to positive and negative infinity, and only look at the curves in the middle for the relative max and relative min. For the max in the middle of the graph, the top of the curve, will be at x equals 0. So the relative max will be x equals 0. And for the min, looking again at the middle of the graph, the bottom of the curve, which was at -3, we'll have a relative min at x equals -3. And that'll be the graph, the zeros, and the max and min for the equation. There are several different types of factoring techniques. The first one, the basic one, GCF, or greatest common factor. If there's a common term like a, you can take out of both expressions, you can factor and write the rest in parentheses. Difference of squares. If you have two terms, so they're perfect squares, you can take the square root of. The factor would be 2 parentheses, a plus b and a minus b. New to Algebra 2, difference of cubes. A cubed minus b cubed. If you can take the cube root of each term, the first parentheses would be a minus b, and the second parentheses is a trinomial. We'll have a squared, and then positive a times b, and then plus b squared. Difference of cubes, we'll have a minus b at the beginning, and the middle term will be a times b positive. Sum of cubes is similar to difference of cubes, but it's the addition of two perfect cubes. Again, taking the cube root, we'll have a plus b for the first parentheses. The second parentheses, the trinomial, is exactly the same as the difference of cubes. The only difference is you have minus ab instead of plus ab. Perfect square trinomials. If you have a perfect square trinomial with a squared and b squared, and the middle term is either positive 2ab or minus 2ab, you can factor that into one factor squared, either a plus b or a minus b. And the last term, grouping. Factor by grouping is when you have 4 terms. We'll factor the first term using greatest common factor, taking out the common term, in this case x, and the last 2 terms will take out the common term, in this case it's y. When you do factor by grouping, both of the 2 parentheses left over should match up, and your terms outside, x plus y, will be your first parentheses, and the parentheses that matched up is your second factor, a plus b. Title of the first section today is factor. First question, 6x squared y squared minus 2x y squared plus 6x cubed y. When factoring, you can look back at the formulas or think about different ways to factor. The most basic way to factor, though, when you have numbers in common, is the greatest common factor. Looking at the coefficients, 6, 2, and 6, we can take out a common factor of 2 for the coefficients. Each term also has the variable x, so we can take out a single x, and each term also has a single y, so we can take out a single y. We can only take out a single x since the second term only has x, and we can only take out a single y since the last term only has y. Factoring from here, we'll take 2xy or divide each term by 2xy. So the first term will be left with 3. Factoring out an x and a y, we'll have 3xy. Second term minus. Factoring the 2 out, we'll still be left with the negative. Factoring the x out, we'll have no more x's. We'll have y squared. Factoring out a y, we'll have a single y left. And the last term, 6, we're factoring out a 2, so we'll be left with 3. Taking out a single x from the x cubed, we'll have x squared, and taking the y out, we won't have y's in our last term. So always a good idea to double check after you factor, see if there's any other terms you can factor out or use any other factor techniques. In this case you cannot.